Okay, we are ready for notes 1B, which is multiplying and dividing exponents with the same base. What we're going to do for these first three is we are going to use properties of exponents to write an equivalent expression. Equivalent just means what it's the same thing as. So on the first one, I want you guys to count up how many threes are here before the equal sign. I see 1, 2, 3, 4, 5. So if there are 5 threes, then that means it is 3 to the 5th power. So you'll fill it in with a little 5. All right. It doesn't matter that there are parentheses here or that there's one outside the parentheses. If it is the same number, if it's the same base, they can all just be multiplied together for a grand total for your exponent. So in the first grouping, I see 4 threes. So the first one is 3 to the 4th power. And it's multiplied by 3 to the, there's only one more here, so 3 to the 1st power. And if you guys have 3 to the 4th and 3 to the 1st, then that's a grand total of 1, 2, 3, 4, 5 threes. So 3 to the 5th power. And so again, what I want you guys to see is in the first grouping, there were 5 all separated out, 3 to the 5th. In the second one, there were 4 grouped together and 1 by itself, but it was still 3 to the 5th total. And then let's take a look at this last one. There are 3 in the first grouping and 2 in the second grouping. So the first one would be 3 to the 3rd, since there were 3. And then the second would be 3 to the 2nd, because there were 2. And that means 3 to the 3rd times 3 squared would still be 3 to the 5th. There's a grand total of 5. So when asked what pattern we see when we're multiplying two powers with the same base, what I want you guys to notice is the answer is going to be whatever that same base is. In our example, the base was 3, with the sum of the exponents added. So 3 to the 3rd, like in this example, and 3 squared added to get 3 to the 5th. The base, 3 itself, stayed the same in all of them. But the exponent, when multiplying, the exponent gets added. So I would put something like the answer, again, sorry about the handwriting, it's really hard to write without a little stylus. The answer has the same base. In our example, the base was 3. So the answer has the same base. Okay, sorry, Mr. Broyles was making an announcement, so we had to pause that for a minute. The answer has the same base, and the exponents were added. Another fancy, probably better math way would be to say the sum. We took the sum of the exponents, but that is the same thing as added, so I'm going to leave it like that. Okay, so let's use the pattern now to complete this equation. 5 squared times 5 to the 5th. If we wanted to, we could actually write out what 5 squared and then 5 to the 5th is, and you could do all of this counting, and that's completely fine. But if you guys know that 5 squared and 5 to the 5th is going to be a grand total of 7 of them, because you know the rule of taking your little squared and to the 5th and just adding them together, you would know that the answer is 5 to the 7th. Okay, take a minute to pause this video and try the 2 problems on the Your Turn and see if you get them right. After you push play, I'll have the answers on there. All right, I hope that you guys knew that 8 plus 5 is 13, so this one would be 7 to the 13th. And then I hope you guys knew that 9 to the 10th, and this is a 9 by itself, and so is this. They could have had a little 1 next to it, but they don't actually have to. They can just be like right there themselves. That would be the same thing as adding these 10 nines, so 9, 9, 9, 9, 9, all the way 10 of them, and so on, and then also 2 more. So I hope that you guys realize that that is 10, and then there's also 2 more. So this one is going to be 9 to the 12th power. Okay, On the bottom part of your worksheet, we're now going to do dividing. So above we did multiplying, now we're going to do dividing. There's a quick little mistake right here at the beginning of the dividing. Our exponent is 4 to the 5th, but if you count them up, we accidentally left off one of the 4s. This should have either said 4 to the 4th, or let's just go ahead and add one more times 4 on there, so that now our exponent is correct. So if you have 4 to the 5th divided by 4 to the 3rd, if you expand that, here's what it looks like. There are 5 4s, 2, 3, 4, 5 on top on the numerator, and then on the denominator there are 3 4s. So what you could do is you could cancel one off the top and one off the bottom for each one and see how many we're left with. And what we're left with is 2 4s on the top. So that's why they have it 4 times 4 here, or 4 squared. Okay, so you guys should, even with just that one example, be able to see the pattern. If we had 5 as a numerator and 3 as a denominator, and our answer was 4 squared, a lot of you guys are very smart and can figure out that that must mean the shortcut is subtracting, and that's correct. So you might put something about the pattern being that the answer, when using the same base, and again, please keep that in mind, this only works when the base is the same. Our base was 4 in this example. So the answer when the bases are the same Okay, so the answer when the bases are the same has a subtracted exponent. All right, we're going to use the pattern now to complete this equation. 6 to the 8th over 6 to the 5th. So if it helps you, you can expand this and you can do 8 6s on the top. 1, 2, 3, 4, 5, 6, 7, 8. And you can do 5 6s on the bottom. And then you can cancel out and see how many you're left with if it helps you to make sense that way. Or the shortcut is just to subtract. 6 to the 8th, 6 to the 5th, that leaves 6 to the 3rd. Okay, now I'd like for you guys to try the your turns at the bottom. So pause this video, try it yourself, and then continue the video and make sure you did it right. All right, I got 2 to the 4th as my final answer on the first your turn. And on the last your turn, that one's tricky. You guys could have either put 21 to the 1st, or a more simplified answer would just be 21, because if you have 21 to the 1st power, that just means that you have 21 one time, so it's just 21.